Welcome to the deep dive. Today, we're really digging into something fascinating, the incredible evolution of coding. We'll trace it from its, earliest days right up to where we are now with AI. And our mission, as always, is to cut through the noise. We've gone through the sources, and we want to give you the key takeaways, understand the past, the present, and importantly, where programming might be going. Hopefully, you'll have a few of those aha moments along the way.
Absolutely. And it's not just about, the tech changing, although that's huge. It's also about a shift in the whole philosophy of coding, what it even means to be a developer today compared to, say, 50 years ago. We're aiming to connect those dots from past breakthroughs to what's just around the corner.
Okay, sounds good. So let's jump back. Early 1970s, that's kind of where the modern story begins, right? With the C programming language.
Yes, C, developed by Dennis Ritchie. It's hard to overstate how foundational it was.
Really the bedrock of modern computing.
You could definitely say that. It gave programmers this unprecedented level of control right down to the hardware.
Yeah.
Super fast, really powerful, very efficient. But, and this is a big but, it was notoriously unforgiving.
Ah, I've heard that. Like one wrong move with memory.
Exactly. A single slip up in memory management and poof, your whole program could just crash.
Yeah.
Gone. It demanded this incredible, meticulous attention to detail.
Wow. So that raw power, being that close to the metal, that's what gave us the building blocks for almost everything else.
Pretty much. Think about it. C was used to write Unix, which is the ancestor of Linux. And its ideas heavily influenced C++, Java, C#, you name it.
It's amazing, isn't it? That demanding nature, while tough, it kind of forced this era of optimization, right? Getting the most out of the hardware.
Absolutely. That's why it's still used for things like operating system kernels and game engines, where performance is just critical. That low-level power defined what was possible for a long, long time.
But I wonder, did that difficulty, that unforgiving nature, also mean fewer people could get into programming back then? Was the barrier higher?
Oh, for sure. It definitely created a higher barrier to entry. The programmers then, they were almost like pure software engineers, really hands-on with how the machine worked internally. You needed serious rigor, almost like an artisan's focus.
Okay, so C gives us immense power, but demands this constant focus on the machine's guts. As software got bigger, more complex, that must have started to feel less like power and more like a drag for some developers.
That's a great way to put it. That tension, that need for something maybe a bit more abstract, a bit easier to manage at scale, that really paved the way for the next big shift.
Which brings us to the 90s, early 2000s, languages like Java and Python starting to rise.
Exactly. And they really changed the game. They brought in concepts like automatic garbage collection.
Garbage collections. So the programmer didn't have to manually track every little piece of memory anymore?
Right. The language runtime handled a lot of that cleanup automatically. That was huge. It removed a major source of bugs and, frankly, anxiety for developers.
And object-oriented programming, OOP, that was big then too, wasn't it?
Massive.
Hmm.
OOP let you think differently. Like building with pre-made components, these objects with their own data and functions, instead of, crafting every single detail from scratch.
Made complex systems easier to design and manage, I guess? More modular?
Precisely. It was a fundamental shift. You spent less time wrangling memory addresses like in C and more time thinking about the overall structure, the business logic, how to solve the actual problem.
So the focus elevated, in a way.
It really did. Less about the machine's details, more about the application's goals. And the tools got way better too around this time. IDEs, integrated development environments, became common.
Right, with things like syntax highlighting, telling you if you misspelled something.
Yeah, and auto-completion suggesting code, plus tools to help refactor or restructure your code safely. It all made development smoother, faster.
Okay, so languages like Java and Python made coding more about problem solving, and the tools helped manage the complexity. But projects were getting bigger, involving more people. That must have led to new challenges, right? How did people start working together?
Ah, yes. That leads us into the era of collaboration and open source. This was another genuine revolution.
You mean things like Git?
Exactly. Git for version control was transformative. Suddenly, tracking changes, merging work from multiple people, rolling back mistakes, it became systematic, reliable.
Before Git, how did people even manage that on big projects? Emailing files, shared drives. Sounds chaotic.
It was often chaotic. Git brought order, and then platforms like Stack Overflow popped up.
Ah, Stack Overflow, every developer's best friend, right?
Pretty much. A place to ask questions, get answers, share knowledge globally. You weren't stuck reinventing the wheel constantly. Plus, the whole open source culture really took off, people sharing their code freely.
Meaning you could grab existing code, maybe tweak it for your own needs, forking it, they call it.
Exactly. You could build on the work of others, collaborate across continents. Platforms like GitHub centralized all this.
The GitHub really did change everything, didn't it? Made coding feel more social.
Social, agile, much faster. It accelerated innovation like crazy. Got a problem? Chances are someone, somewhere, had faced it and maybe even shared their solution.
Do you remember like the first time you used Git effectively on a team or found that perfect answer on Stack Overflow? What did that feel like?
Oh, totally. The first time I forked a repository on GitHub, made some changes, and saw how easily I could integrate useful code someone else wrote, it felt, honestly, like unlocking a superpower. And Stack Overflow.
Yeah.
Countless times it saved me hours, maybe days of banging my head against a wall. It turned programming from this potentially isolated thing into a global team effort.
Okay, so we've gone from C's raw power through easier languages and better tools to this collaborative open source world. What's the next big jump?
Well, the really big leap, the one we're living through right now, is AI integrating directly into coding.
Right. GitHub Copilot. That landed in 2021, powered by OpenAI.
And it wasn't just fancy autocomplete. This thing could write entire functions, generate all that repetitive boilerplate code.
It can even explain code sometimes, right? Like tell you what a confusing block does.
Yeah, it can. It went from this kind of, wow, that's cool experiment, to a tool that tons of developers use, like every single day, very quickly.
And it's not just Copilot now, is it? There are others entering the space.
Oh, yeah. You've got Tabnine, Amazon's CodeWhisperer, and we're even seeing early stuff with voice commands for coding. Imagine just describing what you want built.
Wow. That's a big shift. It feels like it changes the fundamental idea of coding.
It really does. It's moving from, meticulously writing every line of code, focusing on perfect syntax,
To maybe designing the logic, focusing more on the outcome you want.
exactly that. The developer's role is morphing, maybe more like an architect who instructs these intelligent systems, okay, build this component, run these tests, set up the deployment.
But that raises a question, doesn't it? If the AI is writing so much code, do developers lose touch with how it actually works underneath? Like, could we end up with systems we don't fully understand or can't easily debug?
That's a really important concern, the black box problem. It's something the community is definitely grappling with. How do we use these powerful tools without losing that deep understanding?
And the big question everyone asks, will AI just replace developers?
Yeah, the million-dollar question. Look, the consensus seems to be not likely, or at least not anytime soon.
Okay, why not?
Because the role is changing, not disappearing. Coders will likely spend more time on the higher level stuff, reviewing the AI suggestions, refining the design, architecting the overall system, solving the really tricky problems. The core skills logic, problem solving, understanding algorithms, system design, they don't go away. If anything, they become even more critical when you're guiding an AI.
So think of them less as replacements and more as co-pilots.
Exactly. Co-pilots, super-powered assistants, they handle the grunt work, the repetitive stuff, reducing common errors.
Which frees up the human developer to focus on the creative aspects, the genuinely novel challenges.
That's the idea. Let the AI handle the boilerplate. Let the human focus on innovation and complex problem solving.
So where does this all head? What does the future look like? It's kind of mind-bending to think about.
It really is. Maybe coding in 10, 20 years doesn't involve typing code as we know it. Maybe you just describe the problem, the requirements, in plain English, perhaps have a dialogue with the AI.
And it translates that into working, tested, deployed software.
Potentially.
Yep.
It's definitely heading in that direction of higher abstraction.
That sounds both incredibly exciting and, a little scary too.
It is. That dual feeling is pretty common, I think.
But the takeaway for anyone listening, especially if you're in tech or learning to code, is probably familiar, right? Adaptability is key.
Always. Like every major tech shift before, the trick is to learn the new tools, understand their strengths, their weaknesses, and figure out how to use them effectively. Evolve with the technology.
Wow. What a journey we've covered. From C, right down there with the hardware,
And that close to the metal era.
through making it easier with Java and Python, then the explosion of collaboration with Git and open source.
Yeah, the social coding phase.
And now landing squarely in the age of AI copilots, literally changing how code gets written day by day. The speed is just incredible.
It really is staggering. And maybe a final thought for you to chew on as we wrap up. When the tools themselves are evolving so rapidly, reshaping the very act of creating software, What does it really mean to code with purpose? How will you use this constantly shifting landscape, these increasingly intelligent tools, to tackle problems in new ways? What possibilities does that open up for you?